All right, in this lesson, we are going to talk about function composition. And so when you compose two functions together, the output of one function becomes the input of the next function. And so the notation for that has this little open circle. And it's not the same thing as a time symbol, so you have to be careful and recognize the difference. A time symbol would be closed. The little open circle means composition. And so this symbol says f composed with g of x. And so x is still your input. Another way to write this is f of g of x. And so I like to use two different colors. And so you're going to apply the function f after you apply the function g. And so you work your way out, okay? And so g would be first, and then right after you applied the function g, you would apply the function f, okay? And so a quick review of function notation from graphs. Whenever you have something inside the parentheses, that's your x. And so number one says f of 1. And so we're looking for where x is 1. And so that's this line right here is where x is 1. And the function has the point 1, 3. And so the output for number 1 is 3. F of 1 equals 3. Number 2 says g of negative 1. And so once again, that negative 1 is inside. And so we go to where x is negative 1, and we have the point negative 1, 1 on our function for g. And so 1 would be the output. So you got to pay attention to which function you're using, and then you have to pay attention to whether you're given an x or a y. In this case, we're given x's. Okay, back to f. This time x is 3. So x is 3 right here. And on our graph, we have the point 3, negative 1. So negative 1 would be our output for f of 3. Now we're at g of 4. So go back to the g function and go to where x is 4. And it looks like we have the point 4, 4. And so g of 4 equals 4. And so now we're going to look at some compositions. And so whenever you are composing two functions together, this g of negative 1 is what we need to figure out first. And so we figured out up here that g of negative 1 was equal to 1. And so I can replace g of negative 1 with the number 1. And then the problem says f of 1, just taking f of the 1 we just found. So that means I have to go back to the f function, and we see that at f of 1, the output is 3. And so the answer to number 5 is 3. So you're just doing two functions in order from inside to outside. So looking at number 6, we have to figure out what g of 4 is. And so up here, we figured out that g of 4 is 4. And so this problem becomes f of just 4. And then f of 4, we have to go back to the f function. And we see we had the point 4, 0. And so f of 4 equals 0. And so my final answer is the 0. In number 7, we have to figure out what f of 1 is. We figured out earlier that f of 1 is 3. So this problem becomes g of 3. And so we have to go back to the g function. And at 3, we have the point 3, 1. So 1 is the output for g of 3. So that means my final answer is 1. Number 8, we have to figure out what f of 3 is. And we figured out earlier that f of 3 is equal to -1. So that means I can rewrite this as g of -1. So go back to the g function. At -1, our output is 1. We could also see that right here. And so my final answer is 1. Number 9, we need to figure out what g of 3 is first. So going to g, at 3, the output is 1. So this problem becomes f of 1 and then f of 1, the output is 3. So our final answer is 3. And then last one here, we have f of 4 that we need to figure out first. So we go to where x is 4. We had the output 0. So this problem becomes g of 0. Go to g, go to 0, and it looks like we have the point 2, 0, 2. And so the output is 2 when x is 0. And so our final answer for 10 is 2. Okay, so that's when you have a graph. We can also do this when we have function rules. It requires a little more number crunching, but just a quick review of function notation. If this problem says f of 0, we need to plug in 0 for all the x's. Okay, and so there's multiple x's in this function rule, so I like to go ahead and replace the x's with a blank set of parentheses and then fill in the blank with whatever x value they're giving me. Okay, 0 squared is just 0, 6 times 0 is just 0, plus 8, and so my final answer for f of 0 is 8. Here we're doing the same thing, but this time our x is -2, so I'm going to copy down the rule with parentheses where x used to be, and this time our x value is -2. The parentheses are really important for negative values because when you square a -2, it becomes +4. -2 times itself is +4. And then here we have -6 times -2, that's +12. And then we have the +8 at the end. 4 plus 12 is 16, plus 8 is 24. And so my final answer is 24. Now we're looking at the g function, which is x cubed minus 7. So x cubed minus 7. And this time we're plugging in -2 for x. -2 cubed is -8. Subtract 7, we get -15. Okay, back to composition. Work your way out. So first thing we have to find is g of 2. Okay, and so off to the side somewhere, I find out what g of 2 is. My rule is x cubed minus 7. And we're replacing the x with 2. 2 cubed is 8 minus 7. So we get 1. And so g of 2 is the same thing as 1. And so this problem becomes f of g of 2, which is 1. So now we just need to figure out what f of 1 is. And so getting the rule for f, it's x squared minus 6x plus 8. So x squared minus 6x plus 8. And then we're filling in 1 for the x's. 1 squared is 1. 6 times 1 is 6. Add 8. 1 minus 6 is -5. Plus 8 is 3. So our final answer is 3. If you want to write that intermediate step, -5 plus 8 equals the 3. Okay, this next one, we need to figure out what f of 1 is first. Okay, I think we just did that. F of 1 is the same as 3, but let's go ahead and just do it from the beginning. So f of 1, get the rule for f, which is x squared minus 6x plus 8. Fill in the 1. 1 squared is 1. 6 times 1 is 6. Add 8. And we figured out that was 3. And so this problem becomes g of 3. And so now we get the rule for g, which is x cubed minus 7. And this time we're replacing the x with 3. 3 cubed is 27. Subtract 7, we get 20. So 20 would be our final answer. Number 6, we need to figure out what g of 3 is first. Get the rule for g, which is x cubed minus 7. And our x is 3. 3 cubed is 27, minus 7 is 20. We just figured that out earlier. So this problem becomes f of 20. Oh no, this is going to be a large number. Get our rule for f, which is x squared minus 6x plus 8. And we're filling in 20. Twenty squared is 400. 6 times 20 is 120. Not too bad. We get 528 for our final answer. Okay, now they're switching up the notation. So if you want, rewrite it using the parentheses that says G composed with F. And so when you rewrite it using the parentheses, keep them in that order. F is still inside being applied to the 2 first. And so we still have to find f of 2 first. And so f of 2, we get the rule for f, which is x squared minus 6x plus 8. Replacing both x's with a 2. So we get 4 plus 12 plus 8, which is 24. And so this problem becomes g of 24. Oh no. The rule for g says x cubed minus 7. And so we have to cube the 24 and then subtract 7. So 24 cubed. And then subtract 7. 13,817. Okay, last one. First thing I'm going to do is rewrite the notation. So f of g of 0, keeping the same order. And so that means we need to find g of 0 first. Getting the rule for g, it's x cubed minus 7. So x cubed minus 7. 0 cubed is just 0. Subtract 7, we get negative 7. So this problem becomes f of negative 7. Getting the rule for f, it's x squared minus 6x plus 8. Always going back to these rules up here. And this time we're plugging in -7. Remember, when you square a negative number, it becomes positive. So 49 negative times negative is positive 42 plus 8. And then 49 plus 42 plus 8 is the same thing as 49 plus 50, which is 99. Okay, and so for each of these examples, we were evaluating the composition for a specific value. In each case, there was a number inside the parentheses. Now we can find what the actual composition function is in terms of x. Okay, and so here we've got 3 different functions, and we are going to compose them together to find the new function. And so here's where colors might help. And so here our inside function is g of x, and our outside function is f of x. And so I'm going to kind of color code the functions. So f will be pink, g of x will be blue, and then we'll use green for h of x. Okay, and so we are putting g of x inside f of x. So the first thing I like to do is write the rule for the outside function. So f of g of x is what we're trying to find. And so the rule for f is 2x, leave a big set of parentheses, 2x squared plus 3, just looking at this rule here, 2x squared plus 3. But instead of putting in a number, we're putting a function in for x. So I'm going to write the g of x. So once I put g of x in those parentheses, I put the rule for g of x in those parentheses. So recopying the expression, we know g of x is equal to 1/3 x minus 7. Okay, and so if we need to simplify this to standard form, we would have to multiply out the 1/3 x minus 7 squared, and then distribute the 2, and then add the 3. But I'm going to skip that for the sake of this video and just leave it in this form right here. I don't want to mess with the fraction right now. Okay, next we're looking at h of f of x. So our inside function is f of x, and our outside function is h. Okay, so we're trying to find h of f of x. So the first thing I'm going to do is get the rule for h of x, which is just x plus 2, x plus 2, and we're putting f of x where x used to be. Okay, and so in the next step, I'm going to write the rule for f of x in those parentheses, which is 2x squared plus 3. Okay, and so these parentheses aren't really necessary. There's nothing to distribute. There's no exponent, and so we don't really need them. And we can go ahead and combine our like terms to get 2x squared plus 5 as our final answer. Okay, next we are looking at f of h of x. So kind of switch in the order. It's going to give us a completely different function. So f of h of x. Get the rule for f, which is 2x squared plus 3. This might be another ugly one. Oh, it'll be easier. H of x is going inside the parentheses. So in my next step, we're going to write the rule for h of x, which is just x plus 2. So I will show you how to simplify this one. Okay, and so do not distribute this 2 until you square the binomial. You have to follow the order of operations, which is PEMDAS, parentheses, exponents, then multiplication. And so I make my Algebra 1 kids write out the x plus 2 squared as x plus 2 times itself, because that's the same thing. And then you need to multiply the binomial times the binomial. Some people learned FOIL. And so first is x squared, outside is 2x, inside is 2x, and then last is 4. Combine your like terms, we get x squared plus 4x plus 4. Put that expression back in parentheses because we still have that 2 to distribute, and then we have a plus 3. So distribute the 2, multiplication comes next in PEMDAS, 2x squared plus 8x plus 8, and then add 3. And then lastly, we can combine these like terms, 2x squared plus 8x plus 3. All right, I'm running out of room, so let's do one more. Let's do this, maybe 12 and 14. So they're using that other notation, rewrite it using your parentheses in the same order. And so g is my outside function, h of x is my inside function. So get the rule for g, which is 1/3 x minus 7. And h of x goes in for x. In the next step, I write down the rule for h of x, which is x plus 2. And so to simplify this, there's no exponent here, so we're ready to go ahead and distribute the 1/3, which would be 1/3 x plus 2/3, and then we're going to subtract 7. And so to combine our like terms here, 2/3 minus 7, you have to get a common denominator. So I'm going to write the 7 over 1, and then we can get a common denominator by multiplying top and bottom by 3. And so that becomes 2/3 minus 21/3, which is negative 19/3. Okay, and so our final answer would be 1/3 x minus 19/3. Okay, and so let's end with number 14, which is the same two functions, but in a different order. And you'll see changing up the order gives you a completely different function. So h of g of x this time. H is the outside function. G is the inside function. So we get the rule for h of x first, which is just x plus 2, nice and easy. And then g of x goes where x used to be. And so since there's nothing to do with these parentheses, I'm going to get rid of them. And then write down the rule for g of x, which is 1/3 x minus 7. And then we have the plus 2 at the end. So we just need to combine our like terms, which is negative 7 plus 2, which gives me negative 5.